The next topic that you'll need to catch up on is simultaneous equations, and there's two ways that you can solve simultaneous, either by elimination or by substitution. And we're going to start off with elimination, which is basically where we try and eliminate either the x's or the y's by making them the same. We will start by numbering our equations so that any step that we do after that we can always refer to what we're doing. I've got to decide first of all whether I want to make the x's or the y's the same, and in this case I'm going to choose to make the x's the same. So in order to do that, I'm going to aim for both of the x's to be 6x. So I'm going to take equation 1 times it by 2, so that's going to give me 6x plus 4y is equal to 20. And then I'm going to take equation 2 and I'm going to have to times that by 3. So that will give me 6x as well, plus 15y is equal to 9. Again, I'm just going to draw myself an arrow to remind myself that this is the bit that I have made the same. Okay, now I've got to decide whether I need to subtract those two equations or add them together in order to end up with no x's at all. So my two options are adding or subtracting. So if I added those two equations, I'd get 6x plus 6x, so I get 12x. So that's no good. I've got to subtract in order to end up with a 0. So big subtractions then. 6x minus 6x is nothing. 4y minus 15y gives us minus 11y. And 20 minus 9 gives us 11. So now I've just got an equation in y to solve, so I can say that y is equal to minus 1. To get x now, I'm going to sub y equals minus 1 into one of my earlier equations. It doesn't matter which one you pick, it's entirely up to you, but I'm going to go for equation 1. So 3 lots of x plus 2 lots of y is what my equation said, so 2 lots of minus 1 is equal to 10. So 3x minus 2 is equal to 10 when I simplify that. That's going to give me that 3x is equal to 12, and therefore x is equal to 4. I can always double check my answer as well by using the other equation that I haven't done yet. So as I used 1 for my substitution, I'll use 2 to check it. So this is where we're looking now. 2 times the value of x, so 2 times 4, which is 8. And then 5 times the value of y, 5 times minus 1 is minus 5. 8 plus minus 5 does give us 3, so we know that we've got that right. Okay, I've got another two equations here that I'm going to solve simultaneously, but this time I'm going to try and substitute one of them into the other. However, I'm still going to start in the same way and numbering them 1 and 2. Okay, so my idea is that I'm going to rearrange one of the equations and then I can substitute it into the other one, so I end up with just one letter. So in that regard, it's exactly the same as the previous method. Equation 1 looks nicer, so I'm going to pick that. And I can either make x or y the subject of it. Now to make x the subject, I'd have to add 1, so that would be fine. Or to make y the subject, I could divide by 2. That would be fine too. But if I want to avoid fractions, it would be easier to make x the subject. So x is equal to 2y plus 1. Now I've got this value of x, which is 2y plus 1, and I've got an x which I could replace in equation 2. So I'm going to sub that rearranged version of equation 1 into equation 2. So now I've got 3 lots of not x, but 2y plus 1. Then I'll add on y, and that's equal to 24 still. I've got to start by multiplying out my brackets, so I've got 6y plus 3 plus y equals 24. And then I will collect my like terms together, so I've got 7y plus 3 equals 24. I can rearrange to get 7y equals 21, and then divide by 7 to get y equals 3. Now that I've got my value of y, I can put that back into one of the equations. So from here on out, exactly the same as the first method. But it's up to me which equation I want to put it in. Again, 1 looks nicer, so why not use that? So x minus 1 is equal to 2 lots of y, so 2 lots of 3. So x minus 1 is equal to 6, and therefore x is equal to 7. I could just double check that in equation 2. So it should be 3 lots of x, so 3 times 7, plus y, which is 3, should equal 24. 3 times 7 is 21, plus 3 is 24, so we're all good. Okay, so lastly we're on to how can we apply this in a mechanics context. This is the kind of set of equations that you will come up against in dynamics. So we've got two variables, we've got r and we've got x, and we don't know either of them. But we do know that we've got two variables and two equations, so it's going to be simultaneous. Start off by labelling them 1 and 2. I'm going to have a go at this by doing substitution because I've helpfully actually already got r as the subject of equation 1. So I'm going to sub that into my second equation. So I'm going to sub 1 into 2. So I've got 0.5 lots of r, so x sine 30 plus 7.8 sine 60. And then I've got the rest of equation 2, which is plus 7.84 cos 60, and that's equal to x cos 30. Now there's no doubt that having all that trig in there does complicate matters, but at the end of the day all you've got to worry about is rearranging this from this point forward so that you've just got all of your x's together so that you can find what x is. We're going to do it in the same way that we did before. We've got to start by multiplying out the brackets. So 0.5 times x sine 30, so we've got 0.5x, making it really clear that's a capital X and not a times, plus, so I've done that multiplication, now I've got to do this one. Half of 78 is 39, so this is going to be 3.9 sine 60. Then I finish my bracket, it's plus 7.84 cos 60 equals x cos 30. Okay, so looking at the key points where x comes up, it's in this term and in this term. So I'd suggest, as we've got one already on the other side by itself, that we move this one just here across. So we're going to subtract 0.5x sine 30 from both sides. So we'll get the remainder on the left, which is unchanged. But we're now going to have x cos 30 minus 0.5x sine 30. Okay, now it's tempting here to work out what cos 30 is and what 0.5 times sine 30 is and put it into decimals. That can work, but it's not going to be as accurate as it could be. So we're going to instead factorise that, bringing out a factor of x. So that's going to give us x cos 30 minus 0.5 sine 30. So I've just brought the x out as a factor to the front, and my left hand side is still the same. Okay, so to get x by itself, there's an invisible times sign in here, so we need to be dividing by that whole bracket. So we've got 3.9 sine 60 plus 7.84 cos 60 over cos 30 minus 0.5 sine 30. That's equal to x. I'll leave you to finish the rest of this one off because all you need to do now is substitute that into your calculator, find a value of x, and then take that value and put it back into, I would suggest, equation 1 because that's already giving you r equals. So afterwards I would sub x equals into equation 1 and that's going to give you r.